Hi, I'm Ms. Fung. Let's look at determining linear rules if you're given two coordinates or if you're given a table. Now, this is the second video. The first video looks at two different scenarios. If you haven't seen that one, click on the little eye in the corner and it'll take you there. Now, this being the second video, we're going to start with example number 4. What happens if you're given two coordinates? Let's read. Determine the rule for the line passing through the points -1, 6 and 3, -2. What can you do with two coordinates? You can look for the gradient, which is rise over run, or in other words, y2 minus y1 over x2 minus x1. If you've forgotten how to do that one, click on the eye again and look at the second video in the link and it'll take you there. To avoid silly mistakes, if you're not confident with the equation, you can label x1 y1 and x2 y2 and then continue with this section. So y2 is -2, y1 is 6, so we have -2 minus 6 over x2 is 3 minus -1. -2 minus 6 is -8 and 3 minus -1, or in other words 3 plus 1 is 4. So we have -8 over 4, which is -2. So now we have m and we can plug it in our equation, so it becomes y equals -2x plus c. Now what can we do? We need to find c. Now we have two coordinates and we can do what we did in the last video. We only need one coordinate, so it doesn't matter which one you pick. It doesn't matter at all. If you find numbers that you're more happy to work with, pick that coordinate. I'm going to use that one. So 3, -2. So 3 is our x, -2 is our y. Plug it into that line over there. So we have -2 equals -2 the gradient, x, 3 plus c. -2 times 3 is -6. Bring that over to the other side, it becomes +6. So -2 plus 6 is 4. So c is 4. We have c, we have m, plug it into the equation, we have y equals -2x plus 4. What happens if you're given a graph? We can still get two coordinates from the graph. Let's read. Find the equation of the line shown below. So we can pick any two coordinates. I'm going to pick these two because they seem pretty easy to be accurate with. It doesn't matter which one you do, x1 and y1, it could be the other one, and that could be x2, y2, you'll still get the same answers. So again, using the equation, plug in the numbers, we have y2 as 3, y1 as 1, and x2 as 1, and x1 as 2. So 3 minus 1 is 2, and 1 minus 2 is -1. So our gradient again is -2. Now we notice that the y-intercept is given to us. It's right here where it cuts the y-axis. So c is 5. So now our equation reads y equals -2x plus 5. What happens if we're given a table? Now looking at these numbers, we notice there's a 0 there, so we'll circle it for later. And we see that x is going up by 1 as y is going up by, so look, 4, 6, 8, 10, by 2. So we know that x has to be multiplied by 2 to get our y, or in other words, our gradient is 2. So we can plug that into the equation y equals mx plus c as y equals 2x plus c, because we know the gradient. And looking for c, looking for the y-intercept, we know that it's right there. So our equation is y equals 2x plus 4. What happens when you're given a table without the y-intercept? Let's try this. So x is going up by 1, but y is going down by 1 every single time. So from x to y, we have to multiply by -1. Or in other words, the gradient is -1. So y equals -1 times x plus c, or in other words, y equals -x plus c. So now we have to find c. We can use the substitution method, and there's heaps of numbers, so we can pick any. I've picked 5, 6. It doesn't matter which one you pick. So subbing 5 as x and 6 as y, we get 6 equals -5 plus c. To get rid of -5, we have to add 5 on both sides. So 6 plus 5 is 11. Now we have c and m. We can write the equation as y equals -x plus 11. So we've covered two coordinates and a table. Again, the other two were covered in the previous video. You might want to watch it again and have a go yourself. Thank you for watching. I'll see you next time.